Hello viewer, this oscilloscope has gone out of order and before use it needs repairing. Today I will explain you and also demonstrate how to repair this oscilloscope. Maintenance may be divided in two parts. First, preventive maintenance. Under this category, the equipment is regularly checked for any possible loose contact, dry solder. The internal cleaning of the oscilloscope should be done regularly to avoid the accumulation of the dust. A special attention should be paid to high voltage section and the connectors. Any conductive particle in this region may result the arcing. The cleaning of rotatory band switches and the lever become necessary after a period of 1 year. Ball points of the rotatory switches require lubrication. If lubricating part collect dust, clean it by recommended brush. When there is trouble in band switch contact, the contact should be cleaned by acetone or carbon tetrachloride. To get the smooth movement of levers, oil them properly. Clean the lever switches using carbon tetrachloride or acetone to avoid the contact problem. It has been noticed that after long use of equipment, heat is generated inside it. That may develop several faults, such as poor connection, broken or damaged leads, deterioration in components, overheated resistors generally show a charred look, as in this CRO. A burnt out or a heavily loaded transformer gives out a foul smell. It does not mean that the symptoms of visual inspection are only the reason of defect in the equipment. The fault may be anywhere in the circuit, and you will be able to localize these faults only by way of corrective maintenance. To localize the problem in CRO, you may divide your maintenance in two parts. First, the symptoms available in your CRO screen. The second, the variation in brightness, focus or intensity, mainly because of the power supply problem. All these problems are interrelated. Therefore, to repair any oscilloscope, one has to understand at least the working principle of a CRO. First, let us see the block diagram of the CRO. It is the block diagram of an oscilloscope, and here it is power supply section, it is horizontal section, it is vertical section, and this is a display section. Power supply, it is horizontal section, it is vertical section. The main supply, first step down through step down transformer, and voltage regulated power supply is fed to all sections of an oscilloscope for the functioning of circuits. The horizontal section generates the sawtooth and fed to the CRT to generate the beam, and the input to CRO is fed to the vertical section that goes to Y plates of CRT to make wave shape. To take up corrective maintenance, it is advised that first one should consult the service manual of the equipment. During use of an oscilloscope, often you face the problem of mains fuse blowing, pilot lamp does not glowing, pilot lamp glowing but no trace on CRT screen, improper functioning of intensity control, etc. In general, all these problems are created by the power supply section of an oscilloscope, and to repair a power supply is a challenge for a maintenance engineer. The power supply section of an oscilloscope provides different voltages required by different stages. To minimize the variation of either mains voltage or load, these supply voltages are regulated as and where required. Power supply section of this oscilloscope is here. And the power supply section of this oscilloscope is here. The power supply section of this oscilloscope. If you understand the working principle of a voltage regulated power supply, the maintenance becomes easier. The circuit diagram of this oscilloscope is here in this figure. Here in this circuit diagram, this is the step down mains transformer. These are the points connected to AC mains, and it is mains fuse, and this is the step down transformer, provides the voltage to this bridge rectifier, and the rectified voltage is here. This capacitor filters the ripple, and the unregulated voltage is available at this point. This is the voltage regulator. Here in this diagram, the reference voltage is maintained here via this way. This is the comparator, in which the unregulated voltage is provided at this point, and the feedback voltage is provided at the base. This is the correction amplifier, and this transistor TS402 is series regulator, and these are the load sensor resistor. Load is sensed by these resistances and feedback to the circuit in this way, and the regulated output is available at this point. The DC voltage available at this point is fed to the oscillator section, where this DC voltage is converted into high frequency voltage, are available at various points through this transformer. Since the frequency of the oscillator is higher, to rectify these voltages need a smaller capacitor, and multi outputs have been taken from this transformer. Sometimes mains transformer also creates such problem. This is the mains fuse, which is blowing again and again, and the reason is any of the rectifier diode shorted, or the filter capacitor may also become shorted. Another reason for this problem may be either primary or secondary binding of this mains transformer. Remove faulty diode and check by multimeter. The faulty diode will show short circuited. Same is the case with filter capacitor. First, remove the mains connection and search the rectifier diode, which is here, and its filter capacitor is here. Check the short circuiting using multimeter. One of the diode of this bridge rectifier is showing short circuiting, which is the region of mains fuse blowing. You have seen using multimeter that one of the diode of this bridge rectifier is short. Replace it using a good soldering iron. You have removed the suspected bridge rectifier. Confirm it again using good multimeter. If the pilot lamp of this defective oscilloscope is not glowing, check the following suspected component: defective lamp, fuse blown or mains lead open, defective main switch, open primary binding of main transformer, and these components are here in this oscilloscope. Pilot lamp, fuse, defective main switch. This is the main transformer. The primary binding is here, which is connected with the main switch. See in this figure, the main switch, fuse and the primary binding of the transformer are in series. If the symptom of not glowing the pilot lamp may be reason due to open main switch or fuse or open primary binding. Therefore, check one by one. Ensure the CRO is not connected with the mains. Then first remove the fuse. Then check the continuity of the fuse. It shows fuse is open, and that is the reason of not glowing pilot lamp. Put the new fuse. After putting the fuse, check the continuity in mains lead, and still it is open, means either main switch or the transformer primary binding is open. Check it. Main switch. Check the primary binding continuity. Which is okay. For not glowing of pilot lamp, we have checked the main switch, the mains fuse and the transformer. All these are okay. It means now the suspected part is the mains lead. Replace it. Here in this oscilloscope, the pilot lamp glows, but there is no spot or the trace on the CRT screen. The problem may be in low voltage supplies, high voltage supply, open filament of CRT, grid to cathode potential of CRT is improper. Here in power supply, the low voltage section has plus 210 volt, plus 90 volt, minus 12 volt, plus 12 volt. If any of the supply is wrong, it means problem is in rectifier or the filter section of that area or of that particular voltage. If all the voltages of the power supplies are wrong, it means the power supply is not functioning properly. If the low voltage power supply section is okay, it means there is a possibility of high voltage section. If we are not getting the high voltage, which is minus 1500 volt, it means the suspected components are either multiplying diodes or capacitor. Use your good multimeter and check them and remove the suspected part. After checking the high voltage, your next step is to check the continuity in the filament of the CRT and also proper gate to cathode potential. To see the proper potential between grid to cathode, let us see here in this figure. The grid and cathode both are negative, and negative biasing is maintained from power supply. But to accelerate the electron, grid should be more positive compared to cathode, and this ratio is maintained by this potentiometer. Comparator transistor, if either of the junction is open, you will get more voltage at the collector, with the result you will get more output voltage. If collector to emitter junction of this comparator transistor is short, you will get less voltage at the collector, and the net result is less output voltage. The third suspected and most commonly of the problem is regulator transistor. In general, in this regulator transistor, the collector to emitter goes short, with the result regulated output is more. In case any junction of this transistor is open, the output is less. If the short circuit protection of the power supply is not working, first check the sensor resistance and the sensing transistor. Remove them and confirm by multimeter. Ensure that the first regulated output is okay. If everything is okay, it means there is a possibility to get out all the low voltage output as per specification. If still there is no spot or the trace, means check high voltage section. Here the high voltage has been taken from the same transformer. If the low voltages of the power supply sections are okay, the next step is to check high voltage. The high voltage has been generated from the same power supply using multiplier. If we are not getting the high voltage, which is minus 1500 volt, it means the suspected components are either multiplying diodes or capacitor. To check the ST, first switch off the CRO and see the voltage at EST terminal. EST terminal is here. Remove it and first discharge and check its voltage at this terminal. The EST terminal is here. First take caution that the EST point is not touching any metal area. And since here is a high voltage which may be dangerous at the time of measurement, therefore make necessary arrangement that during measurement this point should not touch either to your body or any point in the oscilloscope. If necessary, make some arrangement to hold the lead. Now switch on the oscilloscope. And measure the AST voltage with respect to ground. This voltage is missing, and that may be the reason of not getting traced on the CRT screen. And find out the source from where this EST is generated. Now switch off the oscilloscope and put its EST lead in its proper socket. And now find out from where this EST is coming. And that EST lead is coming here, means this is the EST area where the high voltage is generated. These capacitors and these diodes are voltage multiplier, which are the suspected component for this fault. To check these multiplying diode and capacitor, first remove this EST board using proper screwdriver. Check continuity. Here this diode is showing some problem. Remove from the PCB. Take your good soldering iron and remove this suspected diode. Now confirm it with multimeter. First check multimeter continuity. Now check this diode. Reverse it, and this diode is showing open connection, means the diode is defective. Replace it by new one. It confirms that this diode is open circuited and is to be replaced by new one. Replace this defective diode by new one. Before soldering in the circuit, check this new diode. Which is correct. Fit it in the circuit. After checking the high voltage, your next step is to check the continuity in the filament of the CRT and also proper grid to cathode potential. To have the proper potential between grid and cathode, let us see in this figure. Here the grid has been given the negative potential and cathode has also been given the negative potential. To isolate the electron from cathode to grid, the grid should be more positive compared to cathode, and this ratio is maintained by these adjusting potentiometer. Filament and grid and cathode are here. Let us check at pin number 2 the cathode of CRT and pin number 1 the grid of CRT to see the proper voltages. Also check the continuity in the filament. Number 2 and number 3 pins of CRT are the filament, and they are showing continuity. It means filament is not open. Grid and the cathode both have voltage more than 1000 volt, while the range of this multimeter is only 1000 volt to read DC voltages. To read more than 1000 volt, connect lead at proper place to read more than 1000 DC volt. Let us measure the grid and cathode potential. Since we have to measure the negative voltage, put this positive lead on the chassis and the negative lead at pin number 1. Here the voltage is 1200 volt, and the voltage at pin number 2, that is cathode, is 1500 volt. Means cathode is more negative compared to grid. Means the biasing is correct. Let us check whether this problem of not getting the beam on the CRT screen is solved or not. Switch on oscilloscope and watch your CRT. Yes, we have got the beam, but of poor intensity. Let us find out the reason why the intensity is low. Here in circuit diagram, this is intensity control potentiometer, which is fitted in front of CRO, and we are changing intensity control by changing this potentiometer. As intensity level is low, means we have to adjust this preset which is fitted inside the CRO. Adjust so that the outside potentiometer which is in front of CRO may able to give the intensity control from cutoff to high brightness level. And this is because of the tolerance range of the component. When you have replaced some component, it means you have to readjust your CRO to compensate the tolerance range. Here we have another oscilloscope which has the problem of focus, and this problem of focus may be due to open focus control potentiometer or open beta resistance or bad CRT. Let us see this CRO. Here the beam of this CRO is defocused. The focus control potentiometer in this diagram is here. And the focus problem in oscilloscope mainly because of this open focus control potentiometer or the open bleeder resistance. In certain situation, the focus problem may be the bad CRT. Switch on the oscilloscope. Yes, the trace is available and focus control is okay. Means problem is solved. So far, we have checked the power supply problem, high voltage power supply problem, intensity control problem, and the focus controls. Now, all these were mainly because of the power supply problem. In the next program, we will discuss how to localize the problem for which the symptoms are appearing on the CRT screen.